Okay, we'll just wait for everyone to come back. How do I minimize this? It's interesting. Okay, I think it's better to keep it here. Do we have everyone back now? Okay, yeah. But do I need to share the Excel sheet again? I hope they got it from the last call. Not sure. Okay, so let's start. It's fine. So if you have the Excel sheet I shared, all you need to do is go copy the data here and paste it on. So you copy the data, you paste it on C1, which is fine. It's okay. So we just follow the process I have on the slide. So let me know if you are following.
Go ahead, though.
Okay, great. So you copy your data, you paste it on Minitab, you go to statistics. So you have statistics. So you have where you have file, you have edit, you have data, you have calculate, you have statistics, you have graph, you have the editor. But for process capability, you go to statistics, you go to quality tools, you go to capability analysis, you go to normal. So you go to normal and you choose this data. So you could click on this, it tells you to select, but I prefer double clicking on it. It's better you double click so you don't make, and there are no mistakes. Then you put your subgroup size. As we go along, you understand what subgroups mean. Subgroup means, so when you picked your data, was it just from one point, or you picked it from, let's say, team 1, team 2, team 3, or shift 1, shift 2, shift 3? How did you pick your data? So but for the case, for the purpose of this training, it's just one data point that I have. And so my subgroup size is 1. If you want more details on your graph, sorry, I put my upper spec and my lower spec. For this, I could just use this. And so if you want more data on your graph, you could choose what you want to see. I want to see my lower spec. I want to see my mean, my sample number. You want to see your CP, and what else do we want to see? Your CPK. Naturally, if you, whether or not you click it, it comes. Good. So this is what you have. So it's a simple process. It just immediately tells you this. In the past, I used to plot this. I can't even say that now. I used to use Excel sheets and do all the maths myself just to get this. So Minitab just makes life easy for you, and you have this. So if you look at my data very well, and you can when you have this, you can better describe your points. You can better describe the process. Your lower spec is 4.32, your upper spec is 5.28, and your mean is 4.74. It just tells you, oh, it's tilting more to the upper part of my spec. So it's not it's tilting. So you have 4.7. So you have sample number is 366. Your standard deviation is 0.12. So if you look at this part, your CPK is 1.44. Like we said, your CPK can never be greater than your CP. So the better your CPK, the better your CP. You see, so that's why I tell people most time your focus should be here, trying to get this guy good. You're automatically getting your CPK right. This is more of process capability. It deals more with your sample mean. So it's the overall capability of your process, your PPK. Same thing like your CPK. This is talking about within, but this is talking about your overall capability of your process. All of this here, parts per million, is when you are dealing with DPMO, DPMU. How many defects will you have in a million pieces? So that's what this is about. So this is how easy it would be for you to just get a CPK or process capability report from Minitab. Okay, I hope we're able to follow that. Okay, so there's also an analysis that you can do on a graphical analysis that you can do. I would show us this maybe towards the end, so we don't spend time, that you really want to understand your process. So I did like a capability analysis. I want to know more about this process. I want to know how many parts per million will I be expecting defect from. So in 1 million pieces, you would get 344. That's in 1 million, the number of defects. Even though my CP is 1.63, so it just tells me there's still room for improvement. So when I do this analysis better, there's something interesting. I said the total number of my observations, so 100 or more. Capability estimate should be reasonably precise. So this tells me more. But look at something interesting here. It says my p-value is less than 0.05. You get, so that's why you see my normality graph is it's a fail, though my CPK looks good, and I still have some in spec, but there are some red flags. There are it's looking like it's when I defined, I said it's within consumer specification limits, but it's out of your process limits. So those are the red flags that you have here. When we go into run charts, you would understand this better. So I'll come back to this towards the end. How do you generate this kind of report from Minitab? The Minitab generates this report, so you have your answers. You can just type this into your report and say, this is your analysis. So it does all of this for you. Okay, we'll come back to understand how that happens. Okay, so now we'll be looking at monitoring outputs. That's your dependent variables. So how do you monitor outputs when it comes to, so yeah, you've produced, you have everything, and you just want to check how your process is doing. So it's the outputs that you want to look at in this case. So we can use Pareto for this. Pareto is, for all of us, we know it's the 80-20 rule, where we say 80% of our problems are coming from this. If we can kill it, we'll solve. So it's better. It's not, the 20% might be 10 defects, but what is making your consumer no longer buy your product is 80%, and that 80% is and that 80% is what you should eliminate. So how do you do this on Minitab? So you just will go to Start, Quality Control Tools, and Pareto Chart. The Excel sheet I shared, you can open it. We would use one of them for this. I think we used the defect sheet, the defects. Okay, so let's go back there and go back to Excel. Yeah, so you can copy this. I would not change my Minitab. So try just minimize this. You don't need to change anything, so you don't get into, you don't make it complex. And you paste your result here. So what do? You go to what starts, you go to quality control tools, you go to Pareto. We are looking at defects, right? Those are your defects. Frequency is optional if you want to fill it, but take note, I want 95% accuracy, combine remaining defects into one category after this 95%. That's what I want. So you click OK, and Oh, something went wrong. Nope. Okay, let me see what I've done wrong. Ah, okay, seen it. Let me not save this. No. Okay, so we go again, quality control. Okay, and I click counts so that my number shows. Sorry, let me show you what I'm doing. Okay, so in frequency, you put counts. Good. My variable could be optional, but I think my frequency is counts and it's fine. Okay, better. So this just plots your Pareto. If you look at it, biggest challenge is with okay, so if I want to say my top 3 defects are heat insufficiency going into my furnace, and I have high moisture, I have low bulk density. So if I want to solve a problem, I will look at these 3. But if I want to solve just one problem during my in my problem solving analysis or project, I would focus on heat insufficiency. So this is the simple way to handle Pareto on Minitab. Okay, so cause and effect. So we know it's also one other tool. So yes, I found out that my biggest challenge is heat insufficiency, but I want to do a cause and effect. Like I want to narrow down what my challenges are. So we all know the 4M, 5M, depending on what it is. Is it material? Is it machine? Is it man? Is it method? Interestingly, I know we used to plot this or draw this with our hands on Excel or on Word documents, but it's very possible to do this. Very possible to do this in Minitab. Very possible. So all you need to do is pick your data, take it to Minitab, the same thing. Please let me know if you are following, if you are able to follow. I know it's not. So you just need to pick your data. You would have decided what challenge you have with man, what challenge you have with um, machine, what challenge you have with material, method, and all. So you put that on Minitab, you go to start, quality control to then cause and effect. Then in each of the causes, you put in your, so start, quality control to cause and effect. You can change this name. Okay. Personnel, I was not trained with personnel. It's man that I do. So you can change this, then you click the causes box, this box, then it brings up all of the things that you put. So I like double clicking, I think is the best way. You double click, you put here, you double click machine, put it here, you double click material, make sure it tallies so you don't have the wrong thing. You click here, you double click method, right? Okay. You click here, you double click measurement. Understand that if you don't have up to all of these, you can delete. You don't have to follow them. And you can change the name to suit. I love 4M. I don't do 5M and all of this. You just focus with deliberate 4M, man, material, machine, methods. I don't need to start looking at environment and all of them. I can find where to put them. Okay, so you double click this and you're fine. What's the effect? My effect is low. What did we say our challenge was? Whatever, we can call it anything. Low moisture or low BD. You just put it there. What's the title? Cause and effect for an effect for moisture. Whatever you want to call it. Yeah. So you do that and you click OK. I hope this works. Good. So this is what you get. So you don't need to start looking for how to draw your cause and effect diagram on a paper, or you're stressing yourself trying to get these lines correctly on on a Word document. So this is simple, and this is how you do it. Okay, so graphs and charts. Graphs, I would not say charts. So let's focus on graphs. So we'll be looking at things like a box plot, a histogram, but it's still a, a document that will teach us more about all of this. So a box plot is a very good tool that we could use to understand. I like using it for teams or for problems that could be in groups, because you want to understand which of these teams, like what I've done here is for teams, which of these teams are giving me the are doing well or giving me more of the challenge. When you see a star in box plots, it just tells you it's an outlier, so it's fine. Just forget that guy. It's this, so you have some outliers in this team, in team one, team two. So if you look at my box plot here, what do you see? The teams that I should focus more on are these guys. These guys are doing well, so I need to focus on team one. Yeah, team one more, because yes, team four is doing like, man, extraordinarily well. But I need to understand that I would use team two and team three when I'm as my target. Like, yes, these guys are real human beings. So these ones are exceptional, but I need to work on team one. They are not delivering the right number of cases, or this team one could be a a, a Matthew in a bank, and anytime customers come to him, he delays the most. There's such a long queue on his part. Or team one could be one of the branches of your company, and they're delivering low output. So it depends on how you look at it. So to plot a box plot on Minitab, same. Okay, but let me see what I use. Cases, right? So you copy. I just need the best production output. I think that's better. So I copy that and take it to Minitab. So I'm just using the same tab because I don't want to keep opening tabs. So you can use different sheets as much as you want. And I put my values here. So what do? We go to graph, go to box plots, under 1Y, choose groups. So we go to graph, go to box plots. I chose with groups, yes, with groups. Now for graph variables, you put, so in graph variables, you put cases and shifts. Okay, double click, don't forget. And here you put machine, sorry. Okay, in category variables for grouping 1 to 4, then we enter team. Okay, yeah, teams, double click also. You could want to scale or label, but I think just for the purpose of this, to save time, this is what we are looking at, and you just plot, click OK. You could want to label it, change it to names of people or whatever you want. But this simple way of getting a box plot, now I know where my problem is on my team. It's one guy who sits at the end, he's always drinking tea and coffee. He doesn't pick his calls, or he doesn't respond to his customers on time. That's the guy in team one. Okay, so that's a simple way of just doing box plots. Okay, so I would also, okay, yeah, we should discuss this now. So it's also good to understand what you want to plot and how to choose your graph. So you might be jumping at Minitab for the first time, but you don't know what graph to use. Minitab can help you choose it. It's the same thing with your capability analysis. Minitab can help you choose it. So what do you do? I think I should show us this at this point. You go to assistant. So you go to graphical analysis. Minitab, I have this crazy data and I don't know what to use. So you tell it to help you choose. So should I use any of these graphs? So then it goes to this point. There's what type of data do you have? Do you have a continuous data or do you have a count or summary? We know what a count of summary is, right? So it's can you count it? Can I put it into groups? That's what it's talking about. Can I put it into groups? So yes, is it does it require, is it graphs and summary statistics, or just graph only you want? What do you really want? It asks you these questions, and with these questions, you'll be able to narrow down to what you really want. What do you want to graph? Is it a summary of data or every data point? Oh, I want to do a summary of data. Do you want to examine the center or spread and use a box plot? Do you want to look at distribution like we did with the capability? Then use a histogram. So Minitab also helps you decide what graph you want to plot and how you want to plot. And when you click any of this, then it takes you to fill that. Then you're able to fill this. So this is one other way you can approach this. So that's what it helps you choose your graph. It helps you decide what graph to use. It also, okay, so yeah, so then you decide, then you plot. So you can use it for your Pareto, which were done previously, or your box plot, your bar chart, depending on the type of output that you are trying to. So we also have the check sheets. I think I actually missed using this here, but we have the check sheet. This is I won't say it's an old method, but it's a tally system that we use in. So and it's you could use it more for attributes. I go to the line and I want to see. Okay, like I explained earlier, I use my jig label jig to check if my labels are centered, and I just take a check sheet centered, and I put one. I pick 20 samples and I wrote centered, not centered, and I just use a tally sheet to decide if this is centered or not. So this is an example I have here. So how many of them were centered? How many of them were not centered? You just put that value. You put that value here. So it's a simple process. But interestingly, okay, I didn't put how Minitab does this, but I can show us that later. Minitab also, though it doesn't call it check sheets, as the case is, but Minitab can help you count. It can actually help you count what's how many things you have, in your system. So it can also help you count it. Okay, but when I think when I get there, I'll remember and I will show you. But you can count. But check sheets, yes, we know it's an old process, but Minitab can actually help you count how many you have in that system. Okay, so histogram, same method, same thing. Also used when you're trying to define your problem or trying to see how much problem you have. So a very good example, we could also use the Minitab to solve this. Okay, so I would, in this case, let's go through Graph Assistant, and we want to graph analysis. This time we want to do a histogram, right? Help me choose. Oh, Minitab, I want to do histogram. All of my data are in the Y column. Oh yes, Minitab. So then you choose, I could just choose this for the X column could be teams. Oh, sorry. So teams, and I don't want a normal distribution curve because I'm not looking at process capability. So and Minitab just helps me put it in this format. So the interesting thing about this, why it is different from going through the simple route, is that Minitab gives you a detailed explanation of everything. Team 1, look at where they are sitting. Team 3, they have a widespread. Team 4, superb. 4, they are doing between 600 to 800 cases. And this is their mean, their deviation, everything. More analysis. It tells you how centered they are. It gives you all of this. It gives you the summary at the end. If I were to go through graph, histogram, simple, okay, with groups, sorry, with groups. And I just come here and put cases. And here is teams, right? Minitab will just give me this, exactly. So now you need to look at this and start analyzing, oh, team one, they are blue. Oh, look at them, look at where they're sitting and all of this. See how it's difficult for you to analyze. So most times it's good to use the assistant to help you explain your data. Okay, good. So we go. So same thing for scatter plots. We know what scatter plot is. It's a tool that we use for correlation. I want to understand how temperature relates to viscosity. I want to understand how moisture relates to temperature. I want to understand how volume relates to, or the amount handling time relates to customers being pissed or customer complaints. I want to understand this. This is what we use the scatter plot for. So it tells you that is there a positive correlation or is there a negative correlation? So it tells you all of these things. But how do we do it on Minitab? So it's just to go to graph, you go to scatter plot, and you choose where you want your x, what you want your y variable to be, and what you want your x variable to be. Okay, so we can also do this, but I think I have my data here. Yeah, I think it's better to just use temperature and viscosity for this. So you take your data, you copy, you paste it on Minitab. Oh, sorry. So you go to scatter plots and ask Minitab. Yeah, I just want a simple one. I don't want a regression line. If you want, fine, but I just want a simple one. So Minitab tells you, okay, let's see, what's your my y variable is temperature. What's your x variable, Dominic? It asks you viscosity, and I just want to see the trend. So what do I see here? When I have a high temperature, my viscosity is low. It's at 470. So you can see it's a what? It's a negative distribution. So it's showing that I'm coming down. So when I have a low temperature, then I have a high viscosity. So this is how you could use scatterplot to do a relationship between. So yes, you can also use your graphical analysis to do your scatterplot. Then you get more information. It tells you more about that product, that program. Okay, so that's for all of those. And then control charts. I think this is one of the most used. You could use for inputs and outputs. We are supposed to do this at input stage, and I said no. It's better to do it at the output stage so that you understand how better to use it for both. So it's a simple statistical tool that graphically represents your data. You cannot use a control chart without putting limits. So you need to put, so I tell people have a warning limit, have your control limits, don't forget, then have your specification limit, the one that you know that, or you could call your specification limit your control limit and your process limit is your warning limit. I don't want this thing to go beyond this, beyond my control limits. I don't want it to go beyond my control limits. So I would, I keep a spec that's a little tighter, and I want my warning limit, sorry, then my consumer specification would be my control limits. So we need to understand when we talk about control charts, this is what it's all about. And control charts are two types. You have the control charts for variables, and you have control charts for attributes. A control chart for variables is looking at, like we looked at earlier, is looking at the volume, the weight, the moisture, and all of that. But for attributes, you're looking at the defects. We had one with defects, right? Yeah. So it's looking at defects, counting things that you cannot, no decimal places in this one. So it's just whole numbers, and you have the XR charts for control chart. 10 minutes. Are you serious? Okay, so we need to be fast. I don't think I want to extend this meeting again. Okay, so so then you have the P chart which you use for attributes. Okay, Okay, so these are just examples, things that explain the XR chart. So we have different types of charts for control charts. We have the XR charts, we have the that's the X bar chart, we have the X bar S chart, X bar R chart. So R for range and S for standard deviation. We have this the XR. So this is what I was explaining. So yes, all of these are within spec, right? But you see it's a run chart, but we have some data here that's just at the same point. It's showing a variation. This is a trend chart, and this one shows periodicity. So it's different type of XR charts that we have. On Minitab, we can build this. We can build a run chart. So, so what you need to do is go to statistics, go to quality control tools, and you do a run chart. So we could just use one of the data there to be very fast. No need to copy again. So I use this one. I can use this and just go to quality control tools and you do a run chart. I advise people to use this one most times for, you just want to understand what it is first before you even start thinking of, put your subgroup 1, because I have just one subgroup. I'm not looking at teams now. I just want to see what my graph, what is happening in my process. Okay, yeah, it's looking good. I have some outliers. Yeah, okay, nothing is above the spec. Okay, you just want to see this. That's why you use a run chart. But when you want to go into details, then you now put in the spec. This is you get it. So when you want to do an IMR charts, same approach, control chart variables, then you go to IMR, and you want to understand how many of them are above your specs. You can see the red flags here, the ones that are showing, oh, I'm not going within. So, but this is measuring your median range. Understand that's individual points, but your median range. The X by R chart is measuring the range. So you look at, it takes a graph, it does the range, that's the upper and lower, it takes, separates them, subtracts them, then it plots the range for you. The same thing with the X bar S chart. It looks at your data and it plots your standard deviation of that graph. So you see, so it could be, if you look at this graph, I think I have used the same. You could see an outlier in your deviation, but it doesn't mean that process is out of spec, but it just tells you that, oh, you need to work on it. You're having out of specs on your deviation, but the process might not be out of spec because it's the same process that we plotted here. And you can see for your range, it's within spec, but when you plot for your deviation, for your standard deviation, then you have an outlier. So it just helps you control that. So you could use it. There's a low weight study that I did one time. You could use it to understand your processes. Oh, these are where my challenges are. After plotting, I saw 4 outliers. I had to put my system in place, improve my processes. Then you get everything within spec. But you can see the X bar chart different from your range chart. Then my capability fell within specification. Before your improvements, your CP was 0.87, and after your improvement, your CP was 1.56. It automatically means your CPK will be within spec. When your CP was 0.87 less than 1, you never got a CPK. You will never get a CPK of 1.33. So, okay, so we can also, so this is for attributes. I would skip all of this, but I think we can, I believe we've been able to get a lot. So, but when you want to understand attributes, that's control chart, use a control chart P. It's more for percentage of defects. That's what you're trying to see. What's the percentage of defects in my product? So you're trying to count your defects. So it's attributes based. It's not variable based. So it just, you count and it plots for you. Minitab can also do this for you. It's the same thing. You go to statistics, you go to control charts, you go to attribute charts, and you look at variables, the defects you found, and you put your subgroup size. So it tells you what number of defects these are. So how do you choose your control chart? Minitab also helps you with this. So it tells you, do you have to do a time series plot, an eye chart, individual chart, or an individual median range chart, or you want to do a X bar chart? So look at it. Is it continuous data? That's a variable. then yes, if you say yes, then display control limits. You want to see control limits. Then you go to IMR and X bar chart. But if you don't see the control, you just use a time series plot. If you want to see your control limits, then you use IMR or X bar for variables. Don't forget. If it's for attributes and it's a defective item, use a P chart that I've shown earlier. If it's a defect per unit, don't forget, there are two different things: defective items in percentage, defects per units. We're talking about like DPMU, DPMO. Then you use a U chart. So this is one graphical analysis I did for the same temperature, and you see it plots for us a histogram. It tells us the flow and the outliers that we have, and it tells us how tilted our graph is to the right, on normal. But you see this graph is tilted more to the left hand side. So Minitab does all of this for you, and you are able to it gives you a summary. It tells you, oh, you have at least 50 observations which are adequate and represent the distribution. It tells you, okay, the outliers that you have, where are they? Why do you have them? But you know your process better, so you're able to use this to interpret and explain your process. Okay, so at this point, I think we should ask questions if we have. We have a very short time. I did not schedule a third meeting. But if we have questions, we can ask now. I have this, yes. I can't stop sharing, and we're back in the meeting, right?
Hello, Dominic.
Yes, hi.
Thank you for putting this together. I think it's very good that there's an opportunity like this created for us to improve our skills. I want to say thank you very much.
Thank you. Okay. Okay, that's good. Yes, sure. I think it's for us to be able to use our understand our processes better and understand how to control them. So it's not just to always get the data, but what is the data telling you? What can you do with the data, and how can you process? Okay, you were saying something. Sorry.
Okay, can you hear me now?
Yes, I can.
Okay, so my question is.
I could hardly hear you.
So I've heard about the kinds of variation that can make a process unstable, special cause and common cause. I would be glad if you can explain that very well here. The two types of variation.
Okay, so I should explain the. Okay, so you want me to explain the difference between a special cause and
common cause variation. What actually are they, and okay, how do they affect the process?
Okay, so if we see, maybe I should take us back to our slide. I think I was able to explain that at the beginning. So a special cause variation, which is what you have in a system. I'm looking for a very good example. I'm making, okay, let me use detergent again. I'm making detergents, and my special cause variation would be the variations that I have from my furnace. That's from my heating furnace. So yes, the heat is not giving me the required